to lecture 2. In this lecture, what we're going to be looking at is how do you actually run your experiment. So after you have decided what you wanted to work on, or even if you have not totally decided, but you have just picked one or two areas you want to start experimenting with, then you need to start running an experiment. And running an experiment means you need to start writing codes. Now, for someone who is just starting, you might be overwhelmed, like I was. As am I going to be the one to write all this code? When will I be an expert enough to get to that level of writing all this? You go on GitHub and you check all those. Now I'm going to show you that you don't have to be overwhelmed. So let's look at logging your result. Now, first thing you want to do once you start your experiment is you want to make sure that every thought across your mind, at least every major thought, is logged. If you don't do that, some great ideas are going to slip away by, and you may not remember them, and they may be the breakthrough idea. So I'm going to flip to the spreadsheet on one of the projects that I did, which is a published paper, and here you see how we log the experiment. So first, the file name, because when you're trying so many ideas, you will need to be creating different files, and so you want to keep track of the file names and use a descriptive name, at least that tells what gives an idea of what the experiment is about, and the objective of the experiment. You want to put that. What do you want to achieve? What do you hope to achieve by doing the experiment? Then what architecture you're using. So what kind of model are you using? In your data set, because as you run an experiment, you might start with few data sets. After some time, you might have more data sets, and you may want to switch to more, or you may be experimenting with just a subset, number of instances or number of classes. So you want to keep that there. And the status, you want to make sure, is it pending, something you planned? Is it running? Because if 2, 3, 4 ideas come to your mind at the same time, you want to know which one is actually running, so that you will not be running the same idea on the same machine or multiple machines. Then you want to know when it is completed, so you have to do your diligence. And you need to have people assigned if you have more than many people working on your team. You need to have some remarks and observation. These are just my formulation. You may have a better formulation for your own work. So in your remarks, that's when you actually also talk more about what particular component you have tweaked in this specific instance of your experiment run. Maybe you are just trying to see if you add two losses together, what the result will look like, or if you just use one loss, or if you change the different kind of objective function. Then what you observed, in some cases, maybe you observed some performance, some weird cases, maybe you observe some GPU error, memory error, or maybe something visual, and you say that, oh, the pictures or images are not as clear as it was in the previous instance of the experiment. And here you want to talk about the model, the saved model. This should actually be the saved model, the name that you use to save the model. So in case later on you want to build another experiment on that, you can know what's the name of that particular weight, the weight of the model, and you pick from it. And you use something also unique as to that. As you run your experiment and become more and more, you will see that you need to collapse some of the experiment. You may want to collapse them so that you can move on to the pending and newer ones. So, and you may want to hide them back. Alright, so that's that about logging your experiment. I cannot overemphasize that. You must log your ideas. It's crucial. It's crucial. You put it down, the idea you are trying, the one you want to try, and you keep incrementing them. If it's the same similar ideas, if it is drastically changed, you want to completely give it a new kind of name. See here, so this one is on inception, and you see this one is just the basic, like the vanilla case. But as you move on, I started introducing a feature extractor, so we name it _fe, but we're still using the same instrument. You could see the performance, and that will help you to see the progress of ideas and how things are working, the number of epoch you're training for, and those hyperparameters. Then anyone that give you a very good performance, you may want to color them out so that you'll be able to have quickly look back at them. So I'm going to go back to our slide. Next thing is you want to develop your paper write-up. Now, you do not have to wait until you have a remarkable result before you start writing. Immediately you have narrowed down to a project that you want to work on, you should start writing immediately. Yes, you know what to write. Just write whatever comes to your mind. You refine it. Writing a paper is a lot of iteration. You refine it. You make different copies. And how I recommend, which I find very useful, is using the overleaf. That's what I use. So if you go to the overleaf, you can use the overleaf. It's very good. You log into overleaf, you'll be able to use it because you can collaborate with other people. So see here some of the projects that I have done. Okay, so these are the ones I'm currently looking at now. So you go into the overleaf, and there you can begin to use your overleaf to start writing whatever you feel should be the topic. It might not be absolutely correct, but just put something down, because it's much just the best approach for developing your papers. You cannot have read everything, then one day you now sit down and you want to start recollecting or start looking for all of them and start writing from them. That's not a good approach. You forget some things, you will miss out some things you never even remember. But what you do is, as you're reading, if you read a paper and you see that there is a line or two that is related to your project, then you put that paper, you put that thought down in your paper, in your overview, and you may eventually remove it, but at that moment you put that thought down. And one thing you also do is that you create your references. You create your references file in your overview, which you can name as main.lib, so that as you find those files, you can put them in your references here. So you just paste them into your references, and that should do it. So you have your references here. There are a number of ways you could get your papers. You go to Google Scholar. Google Scholar give you that. So you go to Google Scholar. You can have your papers. You can get some papers from there. And there are so many other resources too. So let's say you are working on computer vision. Let's say you're working on GAN, Generative Adversary Network. You see a lot of papers on that. And either you want to pick the paper in the last, let's say 5 years. So from 2017 or 2018 up to now, you want to start with that and see what people have done. Okay. So here you just come in here, click on site. Now you're using bib, so bb text. I don't want to say that here. You could take that, then you copy this, okay, and you could just copy that into your main.bib here, and that's it. And so in your main.text, you can reference that and say that, oh, you want to so you want to cite that paper. You can cite. You can scroll down to the paper. Generative Adversary Network was used. Okay, you get the gist. You can continue like that, and you can recompile, and you see that. So anytime you have this one is not showing because you have not printed the bibliography here. Okay, so at least you now have the name here, and you can fix things up as you go on. And if you have a thought and you are still missing the idea, you can use question mark, and later you come back and fix that. Alright, so that's developing your paper write-up. The next is submitting to workshop, journal, or conference. Now, as you're developing your paper, you also want to be looking at the possible venues where your work will be read and peer reviewed, and you can get feedback. So this kind of ties back to the lecture 1, where you attend conferences and you see the kind of papers, quality of papers, how people are writing it, what are the content of those papers. Then you can borrow the idea from that and look for similar venues or target similar venues for your own paper. So like in this work now, you cited, you want to see the PDF, you could see the PDF of the work, and you will see where it was published. So this is published in IEEE Signal Processing Conference. So you may target similar ones. And by the time you check the paper itself, okay, it's not available. So you may also go to archive. So archive, ARXIV. Another venue where you could search for papers. So go to archive, click, search there. You can have some of these papers there. It is there or something similar. Okay, so and if you go there and you see what people are doing and how they are writing those their papers, the layout, that will also give you an idea of what kind of layout you also need to put in your own paper. At least you know introduction stands out, and another thing that stands out is conclusion. If you scroll down, by the end you must have a conclusion, so you know conclusion also stands out. So your own work too must have introduction and it must have conclusion. So you begin to, as you read more and more, you begin to what kind of content goes into the conclusion, what kind of content goes into the introduction. It has a reference. Yours too must have a reference as well. Okay, so at least introduction, conclusion, references. Then you also have abstract. You begin to see how the abstract is formulated, what are the content of the abstract. So if you are submitting for this kind of journal, you know what they have accepted in the past years, and you can begin to adapt your own write-up, make it as close as to what they have adapted. How do you formulate the topic? It's an art, comes by an art. As you read more and more papers in your chosen field of research, you pay attention to the way they formulated their own topic, and you also may want to adapt that similar approach. You get intuition as to how the kind of words they are using and how they are putting it. You see, so this is spelled out and they put the acronyms there. And you see this is in capital letters, but these are in small letters. So you get idea from there. There's the abstract. So read that to begin to formulate what should be in an abstract. Okay. So clearing your doubts. How do you clear your doubts as to whether what you are writing, the result you are getting, actually meaningful? Well, the way to answer that question comes with a lot of from different input from different people. The obvious one is the advisor is supposed to give you clues as to whether you are getting good results or if you are not yet getting good results. Sometimes the advisor may be busy, might be more into administrative work and not really pay attention to what you're doing. That could be an unfortunate situation. What you can do is to look for faculties that are working in similar areas, 2 or 3 more. You could set up an appointment with them on your work and you just want to get their input or thought. And you could send a draft of what you want to discuss earlier to them and they could help you read and they'll be willing to give you 1 or 2 insights. Then also when you go for conferences, the opportunity for doctoral consortium where you could meet experienced mentors where you can chat and talk about your work and your results and you could show them these are the results you got. Is this something reasonable or what direction should you be looking at? Then also, of course, when you submit your paper, you will begin to see that the reviewers are going to give you feedback as to maybe you should try more state-of-the-art results or current methodologies, or maybe you should add more metrics to whatever you're trying. Okay, we're going to stop there for now. Thank you and see you in the next one.